This is the MazeBot presentation for MEC 140 by Byron Langston. As the robot gets going here, you can see on the display screen that it reads out an indication of what the robot is actually doing as it executes its various maneuvers between go, stop, back, and right and left turns. The robot's driven by two motors geared to the wheels through very small gears, gearing down for greater torque and mainly to reduce speed. This was due to control issues where it was very hard to time the turns and the other maneuvers of the robot. This was also aided significantly by putting some reverse electrical tape around the wheels to add a little extra grip so that you could really depend on the movement of the wheels. As this robot was very close to completing the maze successfully from the trial run before it, the maze was slightly misconfigured and it got hung up there. As the robot completes its second trial run here, we can discuss how the code presented a bit of a problem because I couldn't differentiate between forward and backwards with the robot. This was because of the counter-rotating nature of the fact that the motors were opposed in different directions. It got a little bit convoluted to figure out which way the motors needed to spin to execute their respective turns or forward-backward motion of the robot as a whole. This was remedied by using macros and functions to simplify the coding process so that I could just use a standardized form to execute different maneuvers between turns and directions of the robot. Although there's two push buttons pictured, only one of them's functional. The other one is just a start-stop button that pretty much fell out of use by the time I got around to testing the robot. The push button will contact a surface when the robot runs into something and will trigger a condition in a if statement in the programming such that the robot will back up, execute a pre-programmed turn, and begin traveling forward again. Construction of the vehicle following the instructions was pretty straightforward. A couple of essential modifications helped though. Swapping out the gearing with gears to slow down the speed significantly helped with control incredibly. Replacing two of the wheels with a caster in the back allowed for much tighter turning radius. Adding a little plate steel also created a convenient place to store the battery as well as to properly secure the Arduino onto the bot itself.